This is the final design for my Tesla type batteries. But I've got a problem. I was hoping to show you this painted up, completely finished, and working. Well, as you can see, it is working. It's giving me a 24 volt output. Now, I've got a problem which I'm hoping somebody can tell me what's going on and how to fix it. You know, I got the fuse indicators, right, so that when I press the button on the front panel it puts a 3K resistor across the output, and if there's a fuse gone it lights up. Wrong. I've completely overlooked something and I can't for the life of me figure out what it is. I disconnected because I was going to check it before I took it apart and sprayed the box. I took a fuse out, one end of the fuse, and when I press the button that LED should light, but as you can see nothing's happening. Now, if I take out the positive connection to that pack and put a resistor between the disconnected wires and negative of that pack, the LED lights because the fuse is open, basically indicating that it's blown. But when I've got it connected and they're all in parallel, it isn't working. I've even put the resistor across the rails here and still nothing. I'm perplexed. My brain just is not seeing what is obviously in front of my face, or I'm being thicker than I normally am, and I've got the monopoly on thick, so if I'm being thicker then I'm really thick. So yes, it's a request for help, and here you can see how they're wired. You got 6 cells in series, and one of the series links is the fuse, and across the fuse is the LED fuse blown circuit. So when the fuse goes open circuit, the current flows through the diode and lights it up. And there's 12 of them all in parallel. Now what is confusing me is if that fuse has blown and there's a resistive short across this point here, why doesn't that light? It can't be because there's voltage coming from this direction, I presume, because it's that fuse that's blown. So it would be this pack that would see the resistive fault. I even went down to a 500 ohm resistor across there and it still didn't light. Burnt my fingers, but it didn't light. And I just have no idea as to what's going on or how to cure it. Yes, I have swapped the wires over to see if that was the fault. No, it isn't. Because as I said, when I disconnected the pack from the parallel rail and put a resistor across the output, across the pack, the LED lit. So that bit is working, but somehow or another, I have no idea why. Because it's in parallel with all the others, it's not allowing this circuit to liven up and tell me that there's a short, or the fuse blown rather. So if you can figure it out for me and give me a solution, or if you can figure it out for me, that'd be brilliant, then I'd know, and I might be able to come up with a solution myself. But if you've got a solution anyway, I would be very, very grateful for all your help. So Mr. Thickalot is either being super extremely thick, super extremely stupid, or he just ain't got a clue, or all the above. But yeah, I'm quite chuffed with the way this has come together. I know a lot of you are going to say, well, why are you making them portable? Well, the reason being is that when I got my nice EV on the road, I will not be charging it at all at any time from the grid. These batteries will be on the Powerwall being charged up on a daily basis, and they'll be used obviously, but when I've got the car ready, I shall use as little as possible in the flat, and then the number of batteries that I would need, I can just disconnect them and carry them out to the car and reconnect them in the car. So it's basically like a universal battery, if you like a car battery. It can go anywhere. But there you are, people, and there's the voltage, but no working, and the push button's fine. I've checked all that, done all that, and it's on the right side as well of the bridge rectifiers. Now I know a lot of you are going to say, well, what the hell are you using bridge rectifiers for? You're going to lose a lot of voltage. Okay, I'm going to lose a lot of voltage, but at the same time it means I've got a meter that is accurate, by the way. These cheaper meters have got a pot on the back and you can adjust them, and so I put my VTEC meter across, and then I adjusted this to what my VTEC meter was saying. So I'm reading the pack, not the bus bar, the parallel bus bar. Also, I didn't want the solar panels to be charging from the end of the pack. They're actually charging from the middle of the pack, and the output is coming from the end of the pack. Now it might be that that's causing a problem, I don't know, but as I said, all help will be gratefully accepted. So please rate, subscribe if you like what I'm doing, and comment, well please comment, good and bad, because that's how I learn. And thank you to all my viewers and all my wonderful subscribers supporting me. Very, very much obliged. But yeah, there you go, people. I hope you all have a nice day, and I look forward to hearing from you.